Hello guys, welcome to Tronic Synergy. If you have not subscribed to my channel, please do so for you to get all notifications when I'll be uploading new fun videos. And today we are going to do an experiment on a boost converter. What a boost converter does is that whenever the output notices that there's a low voltage at the input, then it boosts up so that the output could remain in a constant state of operation. So this is the pot meter that we are going to tune. We'll be tuning it, and once we are tuning it to a low voltage, whenever this detects that there's low voltage at this transistor, then this integrated circuit, the the UA741, will be boosting up this transistor at the base so that more current can pass to ground for this LED to continue running in a normal state. This the positive or the non-inverting input of the integrated circuit is a V reference. It's also a pot meter, the same as this one. So this will be at a constant state. We'll just tune it to make sure that it remains in a constant point. These are diodes that will ensure once this is on, the current here will not flow back to the pot meter, and once this on, it will ensure that current doesn't flow back to the output of the integrated circuit. So the requirements are just simple. You can just take a screenshot of this schematic, and the requirements are right here. You can also take a screenshot. We'll not all use these. There's some that we are going to use others. The most important ones to have is the UA741 monolithic op amp. The switch is not important, we're not going to use it. The LED, you can use whichever color that you have. A transistor, you can choose whichever NPN transistor that you have. I'm using a BC547. And the resistors, the most important are the pot meters. The others we are just going to range. So we can begin our project. So this is my breadboard, and already I've placed my UA741, and the data sheet of it, you should check the data sheet of the UA741 for you to connect the pins correctly. So this is the data sheet of the UA741. Pin number 8 is not connected. Pin number 1 is the offset null. 2 is the non-inverting input. 2 is the inverting input. 3 non-inverting input. 4 is the ground. 7 VCC. 6 output, and 5 is the offset null 2. This is the offset null 1. So we'll go ahead and connect first the ground and the VCC, then the others will just connect them later. So VCC pin number 7, just take a jumper. So that's VCC pin number 7, and the ground pin number 4. So just take this one. Yes, now when that's connected, now we can start off with the circuit. Now we'll go ahead and place the pot meters before the integrated circuit. So we'll start with this one, and then we'll put the other one. So you're going to require 2 pot meters. I recommend you to use 10K. These are 10K pot meter. A 20K is also good, but don't go beyond 20K. But it depends with the voltage that you're using as the supply voltage. So I'm going to place it. Okay. So this one, I'm going to place it just next to it. Just going to place it next to it like that. Okay. Now one of these 4 pins will go to VCC, the other pin will go to ground, the same as to this one. One of it goes to VCC and the other to ground. Yes, now the middle pins are the ones that are going to go to the integrated circuit. So for the first port meter, you are going to take it all the way to pin number, the positive, the non-inverting input, positive, and the positive is pin number 3. So we're going to take from here to pin number 3. Oh yes, let's take it from there to pin number 3, like that. And then this one, we are going to take it, okay, this one is the one that's going to go to pin number 3, so let's exchange that. Like that. And then this one is the one that is going to power the transistor that will be powering the LED. So this one of the jumpers will take it to the inverting input, and the other will go straight to the base of the transistor that is going to be controlling the LED. So we'll go ahead and connect this circuit so that the base of it will be connecting with the middle pin of this port meter. So we'll go ahead and connect this. This is a 1K resistor. So there, that one, then from there we connect the LED, then the transistor. So this is the LED, then the transistor. Like that. Now the other pin of the transistor will connect it to ground. Like that. And the middle pin, there's a diode and there's a resistor from the middle pin of this port meter. So we're going to use a 10K. This is a 10 kilo ohm resistor, and we'll take it from there. Then there will be a jumper. We'll jump it off to here. Then finally there will be a diode that will be directing the power to the base of the transistor. So there will be a diode, like that. Now we are done with this part and this part. So there's also another jumper that is going to the inverting input of the integrated circuit. The inverting input is pin number 2. So we'll take a jumper and connect from here to pin number 2. To pin number 2 of the integrated circuit. Now I think we are done with this part and also this part. Now the output of the integrated circuit will go straight to the base of this using a resistor and a diode. So the output, which is pin number 6, output is pin number 6, will go, pin number 6 will go to the base of this transistor. So we'll take a jumper, this one, and from pin number 6 we will move it, to somewhere around there. Then we'll take a resistor, I'm going to use a 5.6K, and we'll connect that part and that one like that. Then from here we'll go to the base of this transistor using a diode R6, this one, and then from here we'll go to a diode, then from the diode to the base of the transistor. So the diode, like that, the diode to the base of the transistor. Now let's pre-check to make sure that everything that we have connected everything correctly. I think we are good to go. I think we are good to go. Now we can power it to check how it works. Now let's power it up. I'm using a 9-volt power supply. You can use anywhere from 3 volts to power this circuit. Yes, so let's tune it and make sure that it works properly. Once I reduce the voltage at this point, which is the input of this LED, then the LED, which is the output, is kept constant by the integrated circuit. Since the integrated circuit, once it notices the low voltage at the input, it boosts up the voltage at the base of this transistor to make sure that the LED is working under normal conditions. So let me tune it slowly for you to see. Let me tune it slowly. You can see it dimmer than before. Once it gets to a point when this notices, then it's going to boost up the power. So even lower, even lower, even lower. You see, the integrated circuit just boosts up the voltage at the base of this transistor to make sure that the LED is working under normal condition. So let's do that again. Slowly, then it picks up. So that's basically the function of a boost converter. It ensures that the output is kept constant even if the input is fluctuating. So let's do it again. Lower, then it picks up.